Good morning, my dear J Warriors. Welcome to the BITSAT mock test where you're going to do the must-do questions before your BITSAT 2025 examination. And do not take this examination lightly because the college obviously is awesome, one of the best private college in the country and at par with some of the IITs and NITs, of course, with good placements. So please give this exam with utmost seriousness. And not just that, the mock test is very important for you to sit in a timed manner and attempt the entire paper, not just physics, chemistry, maths, English, logical reasoning separately, but all of this together with the exact same exam temperament. Because only then you will be able to crack the BITSAT. It's not just about the knowledge or the theory that you have studied for JEE Mains. Is that right? Good morning, everyone. Hi, Akshat. Hi, Sai. Hi, Sanjay Mohana. Welcome. Jesus Flamingo. Welcome, everyone. I hope I'm audible, visible to all of you. So it's time to begin with the first question coming up on your screen. But before that, I hope you have liked the video because that is your daily ritual. The moment you enter the channel, you are watching any class, even for 1 minute, 2 minutes, 1 hour, you have to mark your attendance. You have to show your love. This is your channel. Keep that in mind. Because of your love and your comments, likes, views, we are able to provide all this quality content. Okay. So thank you for liking and thank you for subscribing, guys. Very good. Yes, next exam preparation also will do and IIT also. Nikhil, yes, we'll be doing it. Okay, don't worry. Nest and IIT will be doing it shortly. All right. So let's begin with the first question. If you measure two quantities A and B, then what should be the correct value of root AB? What should be the correct value of root AB in terms of errors? So this is a question of errors. As you can notice over here that our quantity, whatever is y, is nothing but root of AB, which is nothing but a raised to half into b raised to half. So using the principle of errors, delta y by y will be half will be the power, so delta a by a times of half, and b's power is also half, so half into relative error of b. So this is the formula. Whatever is the power will come outside and you multiply it with the relative error. Keep doing it till all the terms are over. Now let's talk about the basic thing. What is the value of y? So it is root ab. So y being of root ab, a is nothing but this, b is nothing but this, so 1 into 2, so it is nothing but root 2. So root 2 we know is nothing but 1.4, so 1.4 should be there. Is that right? 1.4 should be definitely there. I hope this is absolutely clear. And since till first decimal we are talking all the values, we are taking all the values till first decimal, so don't go till second decimal, because yes, root 2 is 1.414. You might be tempted to write this because it seems to be more accurate, but that is logically not correct. Okay, so only go till the first decimal, so only one of these options will be correct. This option is out of yeah. Okay, it's eliminated now. Now talking about this particular thing, what is the value of delta y? We know the value of y is nothing but 1.4. This is half multiplied by delta a. Delta a is nothing but 0.2 divided by the value of a, which is nothing but 1, plus half into delta b, which is nothing but 0.2 divided by 2. Okay. All right. Now what to do? This will be nothing but delta y by y is equal to 0.2 by 2 is nothing but 0.1, my dear students, and 0.2 by 2 is again 0.1, so 0.1 divided by 2 is nothing but 0.05. So this will be nothing but 0.15. So that is delta y by y, or you can take y on this side. So delta y will be nothing but 0.15 multiplied by the value of y, which we just obtained it to be 1.4. Is that right, my dear students? Correct? So how much this is going to come out to be approximately, my dear students? How much is it going to be approximately? 1.4 into 0.15. Yes, almost like 0.2, almost like 0.2 if I'm not wrong. Yep. So this will be like 0.2. So hence the correct answer to this particular question is option D. Very good. Very good. Good morning. Good morning, Kina. Karthik, the result will be out by around 9th or 10th of May. Okay. NEET 2026 preparation, Anand, will start very soon. Okay. Sir, is JEE 2026 like NEET 2025? I feel JEE 2026 will be more than NEET 2025, because if they have upped the level in NEET only, and in NEET only they are asking JEE advanced question, and this year's JEE was also good level, and still the percentile went till high cutoff 93 percentile. So understand that next year's JEE 2026 will obviously be little bit tougher only. I'm talking about JEE mains. Okay, right. So let's move to the next one. The potential of a large liquid drop when 8 drops are combined is 20 volts, then the potential of each single drop was how much? See, imagine these are your small drops having radius r. Let's say each voltage is V1. There are 8 such drops. They combine together and they give you one single big drop whose radius is capital R, and that voltage is given to be 20 volts. 20 volts. First of all, let's use volume conservation. The total volume of the big sphere will be 4 by 3 pi r cube, and the volume of the small sphere will be 4 by 3 pi r cube, but together 8 of them give you the combined volume of the big sphere. That's what it is. 4 by 3 pi, 4 by 3 pi will definitely cancel out, and we are left with nothing but over here 8 times of r cube is nothing but capital R cube. Therefore, if you take cube root, this will be r, and cube root of 8 is nothing but 2. So r is nothing but 2 times of r. That's one thing. Another story over here is that this voltage is related to the radius as well as the charge. And do not forget that if each charge was small q, then the total charge on the big one will be 8 times of q. So this 20 volts, technically, this 20 volts is nothing but K multiplied by 8Q, 8Q, 8Q divided by the new radius. So this will be nothing but 8 K into 8Q divided by the radius is nothing but 2 times of R. So therefore, this will be K4 Q divided by R. Now I'll tell you one interesting thing over here. This particular quantity that you see, kq by r, q is the charge on a small sphere, r is the radius of the small sphere. That is actually the voltage of the smaller sphere. So technically that will be 4 multiplied by V1. That will be 4 multiplied by voltage of that smaller sphere. So that is 20. So V1 will be 20 divided by 4. So V1 will be nothing but 5 volts. So that is the answer, which is option C. Is that okay? A beautiful kind of question where the charges also get added up and you have to consider the volume being conserved as well. Okay. Yes, next the session PDF will be available after the session is over, right over here in the description box itself. Okay. So after the session is over, right, you will see it somewhere over here. Yep. I hope this is absolutely clear. Cool. Okay. And also some of you are also asking, sir, is there BITSAT test series? It's there in the description box. You can see BITSAT test series, 10 mock tests for 649 rupees. You can see it's right over here. 10 complete syllabus mock tests with analysis, with report cards in a timed manner so that you get the actual feel of the examination. So this is the BITSAT latest 2025 test series. But some of you are asking, sir, can I buy BITSAT with IIT and other tests? The answer is yes. Can you see extra mile engineering tests? So this has IAT, ISER aptitude test, SRM, BITSAT, Amrita, all other tests also are there combined together. The best part is the fees is not much then, because it's just 1,299. So if you are planning to buy any 2 test series also, try to go for this. But if you have requirement of only 1 test series, that is, let's say for example only BITSAT or just ISER, then go for one of these options. Then you will be saving a couple of 100 rupees. But anytime you're planning 2 or more test series, go for extra mile engineering test series. You will be saving money. Okay, understood? All right, let's go guys to the next question coming up on your screen. Here is the next question, my dear students. Okay, see this. An oil drop of radius 1 micrometer is held stationary under a constant electric field due to some excess electrons. If the density of the drop is given, the number of excess electrons on the oil drop is approximately how much? So imagine this is that oil drop and there will be multiple forces acting on it. The first force will obviously be the weight, and the balancing force will be the force of electric field. So the force of electric field will be nothing but the charge on it multiplied by the field, and the weight will be nothing but m into g. Now, because this particular drop is at rest as given in the question, okay, it is held stationary under this action of two forces. These two forces should balance each other. So the charge multiplied by the field will be mass multiplied by g. But mass is not given, mass is density multiplied by volume. So that is going to be equal to the weight, and the volume is 4 by 3 pi r cube, and this into g. Is the field given? Yes. Is the excess electrons given? No. Density is given. How many number are there? Take g is also given. Radius is not given. What do you do, guys? Radius is not given over here. What do you do now? Yeah. What are you going to do? Okay. An oil drop. Oh no, radius is given. My bad. It is given. Yes. Sorry, guys. Okay. Then we can solve the problem. Then there is nothing in it. Okay. So on the left hand side, charge is the total charge. So it will be number of charges multiplied by the electron charge and into the electric field. So it will be NEE. So therefore, N will be equal to density multiplied by 4 pi r cube g, the whole thing divided by 3 times of E into E. Now substitute everything and you will get the answer. Density is 1.26, but that is gram per cc. So 1.26 into 10 to the power 3, right? This will be 10 to the power 3 multiplied by 4 multiplied by 3.14 multiplied by r cube. So this is 1 micrometer. So 10 to the power minus 6 whole cube multiplied by g. G is nothing but 10. Okay. This whole thing divided by 3 value over here multiplied by E. E is nothing but 1.6 10 to the power minus 19 and multiplied by electric field. Electric field is given as 3.65. So this will be 3.65 into 10 to the power how much? 4 over here. That's it. So now you just have to do the math and you will get the answer. Yes, you just have to do the math and you will definitely get the answer over here. Okay, just see how much are you getting this as approximately. Just see how much are you getting this as approximately. How much excess electrons are there? You can just see the number probably. I can see 3.14 over here, 3.65 and 3. One of the 3 will get cancelled. 1 by 3 will be remaining. That is 1.26 is there, 4 is there, 1.6 is also there. Just do the math, guys, and see how much are you getting approximately. Yeah, come on. How much is it getting? How much are you getting the answer as? Just check it out. See if you are getting the answer close to 9. See if you are getting the answer close to 9 units. Yeah, so 9 excess electrons are there. Okay, fine. Let's move, guys, to the next question on your screen. In the given circuit, all the batteries have the same voltage and the internal resistances are the same. How much current is flowing through the branch AB? Well, in order to solve this question, realize that you can consider this E1 and E3 as two batteries in parallel connected to this battery. So the equivalent circuit will be something like this, where you have this battery which is nothing but E2, and then you have an equivalent battery with an equivalent internal resistance just like this. This will be your equivalent resistance, this will be your equivalent EMF. That's it. And then you have been asked how much is the current in it. So in order to find how much is that equivalent resistance, use the parallel resistance formula. So 1 by R will be 1 by R1 plus 1 by R2. So it will be 1 by, how much is it? 4 plus 1 by 4. So that will be 2 by 4, which is nothing but 1 by 2. So R is nothing but 2 ohms. So this resistance is nothing but 2 ohms. What about EMF? So EMF has the formula E1 by R1 plus E2 by R2, the whole thing divided by 1 by R1 plus 1 by R2. So E1 is nothing but how much? 2 volts. So 2 by 4 plus 2 by 4 plus 1 by 4 plus 1 by 4. I think this will just come out to be 2 volts. Very straightforward. 4 gets cancelled. 2 plus 2 is 4. 4 by 2 is again 2. Yeah, so this will be nothing but 2 volts. This was already given to be 4 volts. Now, in order to find out how much current is going to go, that current will be the total EMF upon the total resistance. The total EMF, both of them will add because the positive connected to negative, they are in series. So it will be 2 plus 4, sorry, 2 plus, my bad, 4 divided by resistance, which is 2. So it will be 6 divided by 2, which is nothing but 3 amperes, which is nothing but 3 amperes, my dear students. Just check this out. 2 volts, and this was, oh, sorry guys, this was not 4 volts. Sorry, this was not 4 volts. My bad. This was 2 volts. I wrote this as 4 volts by mistake. So sorry. Yeah, this was 2 volts. So then we can find out the current. Yes. How much is that current? The current will be the total EMF divided by the total resistance. Total EMF will be 2 plus 2 because both these batteries are helping each other, divided by the total resistance. So it will be 4 by 2, which is nothing but 2 amperes. So the answer is 2 amperes going from A to B. So B option is the right answer. B for BITSAT. Perfect. Awesome. Akshat will probably do that kind of discussion in the comment section, not during the mock test, because or else it will be very disturbing. Okay. Moving on to the next one. There is a parallel plate capacitor and it has 2 circular plates. There is a separation between them. The field between them is also changing. Then the value of the displacement current. So this is a question from electromagnetic waves. So if you have 2 plates like this and there is some kind of electric field between them, which is changing, then yeah, if there is some kind of electric field between them which is changing, then the value of the displacement current, is given by permittivity multiplied by rate of change of electric flux. This is the manner in which you find out, the displacement current. Okay, so how do we do this? Well. Electric flux is nothing but the electric field multiplied by the area. But the area is not changing, the field is changing, so area comes out. So I will just get epsilon naught multiplied by area multiplied by, just you will have dE by dt. Now dE by dt is already mentioned over here. The parallel plate capacitor circular plate is also mentioned over here. So I know what is the area going to be. So this particular area, as you can see, the radius being mentioned means the area will be pi into r square. So that is nothing but your area. Okay, so now you just have to substitute everything. What is the value of epsilon naught? 8.8510 to the power negative 12. What is the value of area? That is nothing but 3.14. Radius is 0.1. So 0.1 square. What is the value of rate of change of electric field? Well, that is given to be 6 into 10 to the power 13 units. Is that okay? So just solve this and you will get an answer. Just solve this and see what is the answer approximately you are getting. So that's 9, 9, 6 54, 54 into approximately 3. That's what it will be. 54 into 3 will go into 160s. So I think the answer should be C. Yes, it is C. Perfect. Yeah. Perfect. Yeah. So I just did a simple math in my head. Like this is like 9, 6 are 54. And this is like almost 3 because I made this smaller number big. So it's fair to assume I can make this bigger number small to approximately calculate it. So 54 into 3 will be obviously in the 160s range. It will be 162. So I just made the assumption that it will be around 1667. Yeah, perfect. That's the right answer. Okay, very nice. Awesome, my dear students. Awesome. Very good. Let's move to the next question. The separation between 2 plates of a capacitor is given. What is the electric potential which generates a field of this much between them? See, electric field voltage difference and distance has the simple relationship. Electric field magnitude is the voltage difference divided by the separation. So if the electric field itself is given to be 2000, the voltage difference is exactly asked, and separation is 1 millimeter, which is 10 to the power minus 3. So the voltage difference will be 2000 multiplied by 10 to the power minus 3, which is nothing but 2 volts, So the correct answer to this is option A. Perfect, 2 volts. Come on guys, I want everybody to spam the answer. Cool. Let's go to the next one on your screen. The magnetic moment of a bar magnet is 2m. The work done to rotate the magnet, okay, by 90 degrees in the direction of the magnet, in the direction of magnetic field B by 2 will be how much? So the magnetic moment is given, work done to turn the magnet by 90 degrees of the magnet, which is already in the direction of the magnetic field, is how much? So let's understand this. Imagine the magnetic moment is like this, then it is becoming like this, whereas the magnetic field was like that and remains like that. So this is your magnetic field, which is B by 2, and the magnetic moment is given to be 2m. This is 2m. So you have rotated it by 90 degrees. So just calculate few simple terms. What is the initial potential energy? It is mb cos theta with a negative sign. So minus m into b into cos 0, because angle is 0 now. Cos 0 is 1, so it will be minus 2 and 2 cancels, minus mb. That is your initial energy. Now similarly, what is your final energy state? So it will be minus m into b, which is b by 2, into basically cos of 90 degree. Cos 90 is 0, so final energy is basically 0. So let's calculate the work done. So work done is final energy minus initial energy. So final energy is 0, initial energy is minus mb. So the answer to this question will be just positive mb, which is option number D. Positive mb. Yeah, perfect. Yeah, so be careful, because the magnetic moment itself was given as 2m and magnetic field was given as b by 2. So you need to be little bit careful about that. Another thing is, earlier it was in the direction of the field and then it was rotated by 90 degrees. So the framing of the question, you should understand what is exactly happening. Moving on to the next question. Now, remember, in BITSAT examination, the question level is almost this much only. Don't expect very high difficulty questions. Few questions might be difficult, but they design it in such a way that you will not be able to attempt all the questions. So, keep in mind, it is by design, it's not by flaw, and it's not that it's your duty or it's your right to solve all the questions. Okay, very few students really exactly solve all the questions. Okay, and it is also very risky when you solve all the questions because of the negative marking. So keep in mind, the choice of questions is important. You need to score a bare minimum. I'll make a separate strategy on BITSAT on how many questions per minute, etc. you should solve and what should be the exact paper attempting strategy. Okay, so coming to the next one. Two coils A and B have a mutual inductance. The current changes in the first coil according to the equation blah, where I naught is this much, omega is this much, the maximum value of the EMF in the circuit is. Okay, mutual inductance is given, current is given. So how do I find the EMF? Is it related somehow? Just try to recollect. Yes, the mutual inductance in the second coil is mutual EMF in the second coil is mutual inductance into di1 by dt, the rate of change of current in the first one. Okay, so if you go over here and substitute what is the value of I over here, the first current, primary current, is I naught sine omega t. Now I naught being a constant just comes outside. Sine omega t's derivative is cos omega t, and that omega will also come outside. So this is your E2, but we want the maximum value. So the maximum value will be just this much, whatever is outside cos, because max value of cos is 1. So it will be m times I naught times omega. So now it's just a matter of substituting the values. The mutual inductance is given to be 0.001 Henry. Is that right? I naught is given to be 10 and omega is given to be 10 pi. Right? So 10, 10 and this decimals, 1, 2 decimals will go cancelled out. So you will be just left with 0.1 times of pi volts. 0.1 times of pi volts, which is C for your Captain Shreyas. Yes, you can find me on Instagram and Telegram on this handle. Perfecto. So IBU, in this particular question, there are two coils. This coil is primary, I1. This is secondary. Remember, phi is M times of I. Flux in the secondary is mutual inductance times current. So d phi by dt is M times di by dt. That gives us this expression EMF. E is M di by dt. Remember, just like E is L di by dt, this is E is M di by dt. But this is current in some other coil. This is EMF in the other coil. There are two different coils. So M is directly given to me. Di by dt means take the derivative of this current, which is already mentioned. But I naught is a constant. Sine's derivative is cos. And when you take the derivative, this omega goes outside, right? Because of chain rule. Derivative of sine t is cos t. But derivative of sine omega t will be cos omega t. The whole thing multiplied by omega. That's why. And this guy has a maximum value of 1. So the maximum value of the EMF will be exactly the term outside the trigonometric value, which is M I naught omega. So substituting this, we'll get the answer. I hope, Abhiyo, this is clear. Perfecto, understood. Very good. Awesomeness. No issues. Always ask doubts whenever you find difficulty. The total energy of an electron in the second excited state of hydrogen atom is about minus 1.51 electron volt. Its kinetic energy in this state is how much? The total energy in the second excited state is given. What is the kinetic energy in this state? There is a direct relationship for kinetic and potential. Kinetic energy is the total of negative energy, but negative of it. And potential energy is 2 times of the total energy. But we are interested in kinetic energy, and the total energy is minus 1.51. So it will be nothing but minus of minus 1.51. So it will be 1.51 itself. So the answer is positive 1.51. Is that okay? If the question was on potential energy, then it will be 2 times of minus 1.51. So then it will be minus 3.02. Minus 3.02. That would be answer B, but that is for potential energy. For kinetic energy, it is just simple negative of the total energy. These are direct formulas. Yeah. So understand, Shreyas, over here, that the level of the questions is fairly average. There will be very few difficult questions, like I mentioned before. The number of questions are much higher than your regular JEE mains. Plus, there is English and there is logical reasoning. So keep that in mind. Okay, all of this while saying there is negative marking. So it's not like people don't score good marks, they score really good marks. Okay, and about 300, 290, 280, many people score, and that is what you will need. So it's a very competitive exam at a higher score. Okay, and limited seats are there. Also, the cutoffs keep on changing little bit on the higher side year over year. That's what the usual trend is. That's what we have found. Okay, the projectile is thrown with some speed. The horizontal range of the projectile will be. Now, this particular question, my dear students, what you can do, because the vertical speed and horizontal speed are separately given, just find out the total time of flight first. It is always 2 times the vertical component divided by g. So vertical component is nothing but 4, the whole thing divided by g. So 2 4s are 8. So this will be nothing but 0.8 seconds. Now the range is always the horizontal speed multiplied by the time. Horizontal speed is 3 and the time is nothing but 0.8. 8 3s are 24, so 2.4 meters. So 2.4 meters is B option. That is absolutely correct. These are standard kind of questions, my dear students. Okay, moving on to the next one. After 2 hours, 1/8 of the starting amount of a certain radioactive isotope remains undecayed. The half-life of the isotope is, after 2 hours, 1/8 of the starting amount remains undecayed. So say for example, initially N was the amount of the sample. After one half-life, it will become N by 2. After one more half-life, it will become n by 4, half of it. After one more, it will be remaining only n by 8. So three half lives, as you can see. So three half lives. Three half lives is basically 2 hours. 2 hours. So one half life will be how much? 2 hours is nothing but 120 minutes. So one half life will be 120 by 3. 120 by 3, my dear students, isn't it? So it will be nothing but 40 minutes. So answer for this particular question will be B, 40 minutes. That is the half life. As simple as that. Okay. Sir, please make live class for AEEE. Oh, I wish Mavindan, but I'll tell you something. Yesterday we provided you with two important things. I don't know whether you have seen it. It's there on the channel. Just go over here. I know we're not done concept wise because see, again, the concepts are same like J means. Repeating the same concept, it's going to be unnecessary. Then you'll ask me for VIT, triple E, SRM, everything. So concept wise, it is same like J. Trust me, there is no difference. Anytime you face any difficulty, find any concept. You find any concept, you ask for it, it is there. Okay, because I have taken all the classes. So this particular PDF, you please download it from this particular session. It's a very nice PDF. Plus, I have provided the link of the test series. It's there also in the pinned comments if I'm not wrong. Yeah, model question paper and this extra mile test series. Okay, cool. All right, moving on to the next question, my dear students. Get ready for it. For J means half-life is not there in the syllabus. Yeah, but you know, in BITSAT and all these question papers, you might get a question like that, and you cannot say no. You cannot go on protest and you cannot make videos on that because it's a private college. They can do whatever they want. They might go on and off here and there. Nobody will question. Power of biconvex lens is P diopters. When it is cut into two symmetrical halves by a plane containing the principal axis, the ratio of the power of the two halves will be how much? Okay, so let's see. So biconvex lens, the total power is P. It is cut into two symmetrical halves by a plane containing the principal axis. By a plane containing the principal axis means what? Think carefully. This is your principal axis. There are multiple planes, but the plane which contains the principal axis means like this. Like this. So basically, I'm cutting this lens like this. So I'll be getting one half over here like this and the other half over here like this. If the original lens had a focal length of f and a power of p, then this new one will also have f focal length and power of p, f and power p. It will not make any difference unless you cut it like this. You have not cut it like that. So the question was to understand how it is cut. Lot of people think, oh, moment the lens is cut, tuck, 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 oh, power is half, sir. Power is half. 1:2, 2:1. No, the answer is 1:1 in this because you have to see, visualize the question. So such things are there. See, the level of the question is simple, but in the exam, right, in that hurry, you will definitely make the silly mistakes. You will visualize it something else. So be very careful. That's all I would say. Next one. In YDSC, monochromatic light falls on a screen, two slits separated by this much. The first and the second order bright fringe are separated this much, the wavelength of the light used. First, understand what is the meaning of the first and the second order is separated by this much. It means between the second maxima and third maxima, this is the distance, which is basically the fringe width, which is nothing but the fringe width. So fringe width is already given to me. Light wavelength is asked, and we know fringe width is lambda capital D by small d. Therefore, lambda is equal to beta times small d divided by capital D. So fringe width is nothing but 0.553 milli. Milli is 10 to the power minus 3. Small d is how much? 2.08. So 2.08 milli. So 10 to the power minus 3. And upon capital D, which is 1.80 or just 1.8. So see how much is lambda coming out to be. Just see how much is lambda approximately coming out to be in the order of 10 to the power minus 9. Then when you get it 10 to the power minus 9, write it as nanometers. Forget that 10 to the power minus 9 and write it as nanometers. Just say how much is it coming out to be. 0.5 into 2 is 1. So 1 by 18. 1 by 18. So just see guys. 18 5s are 90. Okay. So 18 6 close enough to 6. I think something like 639 it might be. I think. Yep. Just check this out. Because this is 0.55, right? So it will be slightly more than 100. So 100, 105 and something like that. So obviously close enough to 6, I think. So I think it should be 639. 639. Yeah. So just check it out if it is 639 nanometers. Yep. Just check it out. Close enough to 639. So don't have to sit and calculate it exactly. Even if you get a close enough answer in your mind, do mental math. That's enough, guys. I mean, you don't have to do exact calculations because options are always there. It's not numeric type. The moment it is numeric type, that's where you have the obligation to find it out. Right now, I'm not obliged to find the answer accurately. Even if I get a close enough answer, I have options. So I can use that liberty to choose the approximate answer and saving time. That's what you need to do in the examination hall. Moving on. A vessel containing 1 mole of oxygen at the temperature T, the pressure of the gas is P. An identical vessel containing 1 mole of helium gas and temperature 4T has how much pressure? Interesting. Vessel containing 1 mole of oxygen, molar mass this much, and temperature T, the pressure is P. Identical vessel containing 1 mole of some other helium gas, okay, at temperature 4T has how much pressure? See guys, PV is equal to nRT is applicable for all ideal gases, whether monoatomic, diatomic, hydrogen, helium. So for all ideal gases, there is no question of hydrogen, helium separately. No. Now, an identical vessel, see, this statement means that volume is constant, R is constant, this is 1 mole, this is also 1 mole, so this number of moles is also constant. This clearly tells me the pressure is directly proportional to temperature. So, if for temperature T, the pressure is P, for temperature 4T, the pressure will be 4 times of P. Hence, the answer should be C, direct. Is that okay, guys? So, it was a very direct linear question. Okay. So, pressure was directly proportional to temperature. So, T temperature, the pressure is basically P. So, for T temperature, the pressure will be obviously 4 times of P. It's got nothing to do with that molar mass, etc. A lot of people get confused and stuck in that particular part of the question. Okay, moving on. The fundamental frequency of an open organ pipe is 600. The first overtone of this pipe has the same frequency as the first overtone of a closed pipe. The speed of the sound is this much, the length of the closed pipe is. These kind of questions are also again standard. Let's start with, an open organ pipe, and we are talking about the fundamental frequency, and it is given that the first overtone has the same frequency. Okay, the first frequency will be N, which is 1, V divided by 2 times of L. L1 I'll put. Okay, so velocity is nothing but 330. The whole thing divided by 2L1, that is nothing but F1. Okay, so this is the first equation for the open pipe. When a pipe is open, it is open at both sides. Formula is NV by 2L. Okay, next, let's go to the closed organ pipe. Let's go to the closed organ pipe, and we are talking about the first overtone. First overtone means the odd number will be 3. So the frequency will be, which is nothing but odd number V by 4L. So this odd number will be nothing but 3. V is 330 only, but this length will be some other length. Okay, the first overtone of this pipe has the same frequency as the first overtone of a closed organ pipe. The length of the closed organ pipe is how much? Okay, so this is L2. All right, all right. Now this value is given to me. Just check this out. this particular value is given to me. The fundamental frequency of that pipe is basically 600 hertz. This is already given to me. So just substitute that. So from this, we'll get value of L1. How much will it be? 330 divided by 2 multiplied by 600. 0 cancels. 2, sorry, that's it. 0 cancels. Divided by 3, 11. Divided by 3, that will be 20. So it will be nothing but 11 divided by 40 meters. 11 divided by 40 meters is the length. Now that same length, that pipe is there. Another, no, sorry, the same length, the pipe is not there. The question is that the first overtone of this particular pipe has the same frequency as the first overtone of the closed organ pipe. Now this length is the length of the open pipe. We don't have to find that. We have to find L2 of the closed pipe. So what is this frequency? This frequency is the same as the first overtone of this open pipe. So the fundamental is 600. Fundamental is 600. The first overtone will be how much? It will be 1200 hertz. 1200 hertz. So this F2 will be nothing but 1200. So from this, we'll solve it for L2. So L2 will be nothing but 3 multiplied by 33 into 0. Okay, 4. And this is 1, 2, 0, 0. This 0 will cancel. 33 goes with 3 times. This will go 3 times. So 40. Yep. So that is what it will be. So it will be nothing but 33 divided by 160, but that is meters. So convert it into centimeters. So 33 divided by 160 multiplied by 100, 00 cancels, centimeters. So that is what you will get. Just see how much is it coming out to be. Just see how much is it coming out to be approximately. Is it coming out to be 21 centimeters approximately? 330. Yeah, just see this. Just see this. 330 divided by 16, close enough to 21 centimeters. Just check this out, everyone. Yep, perfecto. Awesome. Okay, perfecto. 21 centimeters, Ganesh, Shreyas. Awesome. So did we have to find this out? No, this was not needed. Achumma found it out. Okay, because the actual question was only for the closed pipe, not for the open pipe. This was for open, this is for closed. This was not needed. Okay, moving on. A rigid body rotates about a fixed axis with a variable angular velocity, alpha minus beta t, at some time t. Whereas alpha and beta are constants, the angle through which it rotates before it stops. Very interesting. Very interesting. Just check it out. This is definitely not so straightforward also. Angular velocity is given to be alpha minus beta t. So when it stops, omega will be 0. So alpha minus beta t will be 0. So beta into t will be alpha. So therefore time will be alpha by beta. So at this particular time, it will stop. But the question is something else. What angle will it cover? Now because omega is given, omega is nothing but d theta by dt is nothing but alpha minus beta t. Therefore d theta will be alpha into dt minus beta into t dt. Now integrate, guys, on both the sides. Integrate and integrate. So when time is 0, when time is 0, what is the value of alpha? Theta, that is 0. Yeah, when time is 0, it has just started to rotate, so theta is 0. When the value of time is alpha by beta, then the total angle covered is theta, which we have to find. The angle through which it rotates before it stops. So it stops at this time. So the upper limit is this particular alpha by beta. Now let's see what will it be. So this will be nothing but theta minus 0 will be alpha into alpha by beta minus 0 minus beta into, this is t square by 2. So it will be alpha by beta whole square by 2 minus 0 square by 2. Okay, perfecto. So therefore theta will be equal to alpha square by beta minus 1 by 2. This will be beta into alpha square by beta square. So this will be alpha square by beta only. So 1 minus half is half. So it will be half alpha square by beta. So the answer is half alpha square by beta, which is option A. That's it. That is the answer. Cool. So you just had to do the integration part. And how I did the integration is omega is rate of change of angular position. So take dt on the other side. I will integrate to find out the angle. The limits are very important. When time was 0, angle was nothing. But when time is this value, then the total angle covered is theta. That's all. Option A. Perfect, Ganesh. Yes, perfecto. Amazing, go guys. Moving on to the next question. A ball falling freely from some height hits a surface is this much. Then the ball will hit the surface second time after how much time? I'm assuming in this question G value has to be taken as 9.8 because of this particular value, because usually 4.9 is a multiple of 9.8. So I'm guessing G is 9.8. Okay, so a ball falling from a height and hits the surface at 4.9 meters per second. I'm assuming, oops, I think the unit is wrong, guys, over here. Printing mistakes are there. I think the height shouldn't have been in meters per second. It should have been just in meters. This is fine. How can the height be in meters per second? So maybe then we can find out the speed with which it hits the first time. It will be root of 2g h. So g value is 9.8 and height is 4.9. So 4.9 into 2 is nothing but again 9.8. So root of 9.8 square is 9.8 meters per second. That is your velocity. So that is a velocity with which it hits the surface. It hits the surface the first time. Velocity with which it hits the surface first time. Now what will happen? It will rebound but with a lesser velocity. Let's say I call it as v2. It will go up and again hit the second time over here. It will hit the second time over here. The question is, after how much time will the ball hit the surface the second time? So that time is nothing but 2 times v2 by g. So 2 into v2 by g. G is 9.8. Velocity I do not know. How do I find this velocity? Use the concept of restitution, my dear students. The concept of restitution says it is given as 3 by 4, right? Yep. So concept of restitution says it is the speed of separation upon the speed of approach. Approach is nothing but v1, which is 9.8, I believe, and the separation speed is v2. So from this we get the value of v2 as 9.8 multiplied by 3 divided by 4. So substitute that over here. 9.8 multiplied by 3 divided by 4. 9.8, 9.8 cancels out. Correct? 9.8, 9.8 cancels out. 2 and 4 cancels out. So 3 by 2 will be remaining. So 1.5 seconds. So 1.5 seconds is B option. That is absolutely correct. Perfect. Okay. Great. Sujit, you're talking about NSCP as in like the Olympiads. There is quite some time, right, for it? Yeah. Okay. Moving on to the next one. A pendulum of certain mass and length is released from rest at some angle. The power delivered by all the forces acting on the bob at 30 degrees will be how much? Take G as this much. Okay. So see guys, the bob of the pendulum is released from 60. Eventually it will make some new angle, let's say 30 degrees somewhere over here, and it will be having some velocity like this. And okay, so this angle was 30 degrees and this whole angle was 60 degrees. So if you drop these horizontal lines, things will become more obvious what is happening. So clearly there is some height by which it has come down. If the pendulum length is given to be how much? 1 meter. If this is 1 meter, then this much height will be 1 cos 60, which is nothing but 0.5 meter. And this whole height will be 1 cos 30. Cos 30 is root 3 by 2. So it will be root 3 by 2 meters. So the height by which it has actually come down by the height by which it has come down by, that h will be root 3 by 2, which is this height, minus this height will be this remaining height, minus basically half. So it will be root 3 minus 1 by 2 meters. Why do I need this? So that I can find out how much is this particular speed. The loss of potential energy goes into kinetic energy that will be needed for calculation of power. You will see how. So I can say the potential energy which is there, which is mgh, will completely go into kinetic energy, which is half mv square. So G is basically 10, H is nothing but root 3 minus 1 by 2. Mass has got cancelled, half multiplied by V square, 2 gets cancelled. So V square will be 10 multiplied by root 3 minus 1, or V is root of 10 multiplied by root 3 minus 1. Now that's not done. See, what will happen is over here, the gravitational pull mg will be like this, but a component of it will act this way and this way. This is mg, this is mg, this is mg cos 30, and this is mg sine 30, and the power will be the force along the tangent multiplied by the tangential velocity. Force along the tangent is this one, mass is 1, g is 10, sine 30 is half, and velocity is exactly this one, whatever we found out. So root of 10 multiplied by root 3 minus 1. Yep, that is what it is. So 10 by 2 is nothing but 5. So it will be 5 multiplied by root of 10 multiplied by root of root 3 minus 1. That is what the power will come out to be. Now you can do the math, it is not that difficult. Root 10 will be 3 point something. So 5 3s are 15. So now root 3 is 1.7. 1.7 minus 1 is 0.7. Root of 0.7 will be less than 0.7. Yeah, it will be less than 0.7. Okay. So this was 15 and you are multiplying with the number less than 1. So it will be less than 15. 100% it can't be 20, it can't be 24, it can't be 0. It has to be option A. You don't sit calculate. Are you seeing it? I'm not obliged to calculate any of these things. I have the liberty of these options, and use your brain and common sense and see approximately where the answer will lie. So then you can say 13.4 watts. That is the answer. Is this clear, everyone? Yeah. Rishik, I have already made a video for AEEE. Just check it out. The entire PYQ's expected questions. Okay. I have made a separate video where all the PDFs are attached and also test series. And also before that, I have given you the strategy for Amrita entrance examination. Okay. Last minute sure shot strategy also I have made. Please watch both these videos. Okay. Got it, my dear students? Perfecto. Let's go then. Let's go to the next one coming up on your screen. The initial speed of a body is this much. The force on it is for 4 seconds. Then the impulse of the force is how much? Well, impulse in a force time graph is nothing but the area under it. Area under it. All you have to do is just figure out the area, nothing else. So calculate each and every single area separately. For example, this area, which is the area of the triangle over here. I hope you can see it. This particular triangle. So that will be half multiplied by base, which is 1.5 multiplied by the height. Similarly, you will get nothing but you can say this particular rectangle till here. Okay, directly you can find it out. Okay, so how much will that be? It will be base 4 minus 1.5. Is that right? So that will be 2.5. So 2.5 is the base multiplied by height, which is nothing but 2. So that is the area of this particular part. Then you will also need the area of this part, which is this much, which is a trapezium. So the area of a trapezium is half into the height, which is nothing but 1, into sum of parallel sides. This is nothing but 1. This side is 1, 1.5 to 2.5 is 1, and this is nothing but 1.5, so plus 1.3. So just add all three of them and you will get the area. So area under will be nothing but half multiplied by 1, half multiplied by 1.5 multiplied by 3 plus 2.5 multiplied by 2 plus half multiplied by 1 plus 1.5. Do the math and see how much are you getting, guys. Just do the math and quickly tell me how much is the answer that you are getting. Yep. 2.5 to 2 is 5. 1 plus 1.5, 2.5. 2.5 divided by 2 is 1.25. So 6.25. Okay, so the answer is going above 6. So C and D is eliminated automatically. Either it is B or A. Okay, so 15, 2.25. Just check it. Is it like 8.5? Option A. Is it like option A, 8.5? Just check it out. Yep, perfecto. That is the correct answer. That is the correct answer, my dear students. Okay, cool. Let's go, guys, to the next one. Find the, okay, for a hydraulic constant stress on an object, the fractional change in the object's volume and the bulk modulus are, how are they related? Okay, how is this related? For a constant hydraulic stress, now we all know that the bulk stress by the bulk strain is the bulk modulus. So the bulk modulus is bulk stress, which is constant. The bulk strain is nothing but delta V by V. So clearly delta V by V is a constant divided by B. So delta V by V is inversely proportional to B. Yes, is inversely proportional to B, which is C option. Perfecto. Is that right? Perfecto, everyone. Awesome, my dear students. Awesome. Let's go, guys, to the next question on your screen. There is a man of mass who starts falling towards the planet. As he reaches near the surface, he realizes that he will pass through a small hole in the planet. As he enters the hole, it's not roll, it's hole. We see that the planet, oh my god, so many spelling mistakes are there. We see this should be pass through a small hole. As he passes through the hole, he sees, we see that the planet is really made of two pieces, a spherical shell of negligible thickness of mass 3m by 4 and a point mass m by 4 at the center. The change in the force of gravity experienced by the man is how much? Let's understand it. So he originally feels that he is on a planet with a small hole in it like this. Okay, and this person is falling down and he will pass through that small hole. He will pass through that small hole and there will be a change of behavior. Okay, now what is happening? He sees that the planet is made of two pieces, a spherical shell of negligible thickness. That means the planet is like a shell. This is a shell whose mass is 3m by 4 and a point mass m by 4 at the center, and there is another point mass m by 4 at the center. So when he's inside, what happens? When he's inside, what happens is the shell applies no force. The shell applies no force, and the only force is due to the point mass. So the new force on that man will be G m by 4 into m divided by r square. G mm by r square, that is the new force as it just enters inside. But when he is outside, the shell behaves like a point mass, at the center. So the force which is acting previously, the older force, will be as if the total mass is m So it will be gmm divided by r square. So, it will feel like there is a total mass of 3m by 4 plus m by 4, which is nothing but m. So this is the old force. But the question is, what is the change in the force of gravity? That is what the question is. So the change in the force of gravity will be this minus this. So g mm by r square minus g mm by 4r square. 1 minus 1 by 4 is 3 by 4. So 3 by 4 gmm divided by r square. So this is a good question. Option A should be the right answer. Perfect. It is the correct answer. No, it is not option C. Be careful. The question was find the change in the force. The change in the force is asked. Be very, very careful. Moving on, next one. Electric field due to a charge at this point, which is at the origin, is how much? Okay. So first of all, what is this particular point placed in? This is in the xy plane, as you can see. This is in the xy plane. Our charge is over here, and the charge distance is mentioned. So the electric field at this particular point will be like this. The electric field at this point will be like this. It will depend on this distance. How much will this distance be? That distance will be root of x coordinate square, y coordinate square plus z coordinate square, which is nothing but root of 30 square plus 30 square plus 0 square. So it will be nothing but 30 root 2 meters. So what about the field? The electric field in magnitude will be k q divided by r square. In this case, r is d. So Coulomb constant is 9, 10 to the power 9. Charge is 8 into 10 to the power minus 3 micro. So 10 to the power minus 6 again. Whole thing divided by distance. Distance is 30 root 2, then the whole square. So this will become 9 multiplied by 8, minus 3 minus 6 plus 9 cancel. 30 square is 900 and root 2 square is 2. 9 cancel, 8 and 2 cancel, 4 divided by 100, which is 1 by 25. Is that right? Just check it out. 1 by 25. But that was in centimeters. I'm so sorry, guys. I put meters over here. So this should have been centimeters. So when I multiply over here, there should be 10 to the power minus 2 square. So minus 4. So everything will change. So into 10 to the power minus 4. So 9 cancels. So these two 0 cancels. 8 and 2 cancels. So 4 will be there. Yeah, and this will become 10 to the power minus 2. So it will be 400 Newton per Coulomb. Now, this 400 Newton per Coulomb will have two components, one here and one here. Both will be equal, Ex and Ey. Ex and Ey. So Ex component will be E cos 45. So E cos 45 means 400 cos 45, which is 1 by root. So 400 by root 2, which is also, you can say, 200 multiplied by 2 by root 2, which is 200 root 2 Newton per Coulomb. So each component is 200 root 2. So 200 root 2, okay, I cap and j cap. 200 root 2 I cap and j cap, which is C option, not this. D option is 400 multiplied by, this is divided by. So be careful, guys. A lot of people said D option. No, that is not right answer, guys. It is C option. Okay, perfecto. Let's move to the next one. The x time graph of a particle performing SHM is shown. The acceleration of the particle at 2 seconds is how much? What is so special about 2 seconds? Observe carefully. This is 2 seconds. This is what it is. This is maximum displacement. Max displacement only happens at the extreme position. And at the extreme position, the acceleration is also maximum, and it is a omega square. It is a omega square with a minus sign in this case, because x is positive, acceleration will be negative. So keep this in mind. If x is positive, then acceleration is negative. So that's why minus sign over here. It's opposite. If x is negative, a will be positive. Amplitude, how much is it? 1, is it? Yeah. Omega, oh, we have to find that omega out. Not that big deal. So what's the time period? This is basically the time period. So omega will be 2 pi by time period, which is 2 pi divided by 8, which is pi by 4. So put that pi by 4 over here and square it. That's it. So it will be nothing but pi square by 16 with a negative sign. So it will be nothing but negative pi square by 16. So negative pi square by 16 is C option. That is absolutely correct. Meters per second square. Cool. So to find omega, we saw the entire duration and omega was 2 pi by time period. So nothing was directly given. Everything had to be interpreted graphically. There was no other option, no other way for this. Okay. Great. Cool. Let's go, guys, to the next question on your screen. In the following circuit, assuming point A to be at 0 voltage, then what is the voltage of point B? Okay. I think most of the things are given. This is 0 volts and we have to find out what is the voltage at point B. The easiest pathway which I can see is this one, I believe. So let me go via this path over here. Okay, let me go via this path, guys. See, observe what will happen. So voltage at point B will be voltage at point A, okay, plus voltage drop across R plus voltage drop across that EMF across R and voltage drop across that EMF. So that will be VB. So what is VA? VA is 0. Voltage drop across that resistance. Current is going in this particular manner. Can you see that? Current is going 1 ampere. Resistance is not given to me. Resistance is not given to me. Oh, so we cannot do it like that. Okay, so skip, guys. No point doing it like this. No point doing it like that. So we have to think of some other way because R is not known. So how about this path? This particular path, but you will be asking, sir, this current is not given. So we can find that out by Kirchhoff's current law. 3 amperes coming in, 1 ampere coming out. So obviously the remaining 2 amperes should go down over here. So obviously the current over here will be 2 amperes. Everything is known. Now we can do it. So the voltage at point A plus voltage across that 2 volts plus voltage across that 2 ohm plus voltage across that 4 volt battery is going to give me voltage across point B. Kirchhoff's law starting from here to here. So what is VA? It is 0. Voltage across 2 volts. I'm going from negative to positive, so it's a jump. So it is plus 2. Voltage across 2 ohms. I'm going against the current, so it is plus IR. I is 2, R is also 2 ohms. 4 volts, I'm going from positive to negative, so it will be negative 4 is nothing but VB. So therefore, VB will be 2 plus 4 minus 4, which is nothing but 2 volts. So that is the answer. So VB is 2 volts, which is B option. Absolutely, absolutely correct. Is that okay? Everybody with me? Perfecto. So you have to figure out which is the best way to reach here. I used Kirchhoff's current law to find 2 amperes. It was not given to. Okay, great. Moving on. Next question on your screen. A charged particle moving in a uniform magnetic field loses energy. The radius of curvature changes by how much percentage? The radius is given by mv divided by qb. Mass into velocity is momentum, and momentum is root of 2m kinetic energy by, and this is q into b. So therefore radius is basically, you can say, some constant multiplied by root of kinetic energy. Okay, this is what it is. Now it is mentioned that it loses 16% of its kinetic energy. Okay, so I can do one thing, constant multiplied by k raised to half. So if I write delta r by r, this is approximately half times delta k by k. So if I measure change in the kinetic energy in percentage, I'll get change in the radius also in percentage. So half into kinetic energy changed by 16%. So that will give me 8%. So the radius has changed by approximately 8%. I know this answer is not exact because I'll tell you why. Because 16% is a huge percentage. Technically, I shouldn't be allowed to use this formula. But it's okay. When the options are like 8, 4, 10 and 16, it's fine. It's not going to affect you much. The right approach would have been The correct, see, this is an approximate approach. The right approach would have been the original radius is some constant into root k. The new radius is constant into k has decreased by 16%. So the new k will be the old k minus 0.16k, which is nothing but 0.84k. So you're going to put 0.84k over here. And then you will say percentage change in R will be nothing but, you will say R minus R1 divided by R multiplied by 100. So then R will be C root K minus C into root of 0.84K, the whole thing divided by C root K and multiplied by 100. C and root K will cancel. So 1 minus root 0.84, this whole thing multiplied by 100. This will also come out close enough to 8%. But this would be the actual way in which you should be doing it. But it's okay because the options are not close. Is this understood, my dear students? Perfecto? Okay. Great. Let's go ahead to the next one. For formulas, for NEST and IIT, I would suggest you to watch this. This is one of the best session. There is a reason. See, when there is an artist and if he makes one of the best art possible, then unless that artist finds, oh, there is a better drawing or better art or better, masterpiece that I can create, that artist will not create another one. So I have already created the best masterpiece for all of you. Just search for formula. Just search for formula. Do you see, where is it? Physics. Where is physics, man? I'll search for physics. Physics formula. Okay. Complete physics formula revision. This one is there. This is a almost 7-hour class. Complete revision, guys. Although I say it is for JEE, syllabus is the same. Formulas are the same for IIT or JEE Advanced or NISER, whatever institute you are preparing for. So watch this. This is a masterpiece. Okay. Got it, everyone? I hope, Dimitri, it's absolutely clear. Moving on to the next question coming up on your screen. There is a bob of a pendulum lies at P, reaches Q, loses 10% of its energy due to resistance. The velocity is how much? Okay. Ideally, what should have happened? The potential energy should have got converted into kinetic energy. But because it loses 10%, that means only 90% of the potential energy gets converted into kinetic energy. Okay. So what's 90%? That is 9 by 10 of potential, which is mgh, is equal to half mv square. Mm cancels. So 9 by 10, g is basically 10, height is 2 meters, is equal to v square by 2. 10 cancels, right? So v square will be 9 multiplied by 2. So v will be 3 multiplied by 2, which is 6 meters per second. So 6 meters per second is option A, of course. So this was the catch in the problem. 10% is lost. So 90% only of the potential energy is getting converted into kinetic energy. So that way you can easily get the answer. Okay, cool. Fine. So let's see. Oh, last 2 questions. I think we can give it as homework. So I think we can do that as homework. So this question, fine. Just try to do it as homework. The answers are there on the next slide, so that at least you will solve something and you will be compelled to do something. Okay. So an electron gun potential difference is given. What will be the speed of the emitted electron? This is a nice question. And the next question is this. In the given cycle, what is the heat absorbed during the process for an ideal monoatomic gas? Understand, not all the processes will be heat absorbing. Only certain processes will release the heat. So identify which of these 4 are absorbing and then solve the problem. We have solved such questions before this also. So this is also your homework question. Solution, answer key is there on the next slide. So if you download the PDF, you will get it, of course. I'll be putting up the PDF after some time. Okay, it will be there in the description box or even in the comment section. Keep that in mind. And of course, you have the BITSAT test series. The link is there again in the description box of this particular video itself. So if you have not yet enrolled into the BITSAT test series, I would highly urge you to give at least these 10 mock tests that will prepare you for the upcoming examination. Okay, it's there for a very minimal price with analysis, test results, ranking, everything, 650 rupees. Okay, so make the best use of it if you have the resources. Don't just practice questions and go to the BITSAT exam. That is not the right strategy. You will definitely not get a good mark if you just practice questions and go. That's not enough. You have to give mock tests. Cool. All the best. Thank you for liking. If you have forgotten to like, please like the session and subscribe to the Vedantu J English channel. See you guys. Bye bye. Have a great time.